Hi everyone, this is IASP 455, Secure and Intelligent Programming. Um, the topic that we are going to do today is steganography, which is the last topic that we planned to do cover in this semester, steganographies. Before we get into the techniques of steganographies, I want to make an announcement. The final exam is planned in this way: December 12th, 13th, and 14th. 12th, 13th, and 14th. So you can come in and take one of those time frames. So there is no second chance, only one time. So you need to come, and once you start, that you have to finish it. Every question, I think there may be buttons: complete or submit, whatever the buttons. So you need to make sure that you click press button, and as you finish all the question, at the end, I think there is another button, maybe submit. In that way, you can complete. Some of the cases I received some questions from the students. Hey, I mistakenly this and that and that. Please do not do that. This one-time exam. This is a final exam. Due to the time restriction, there is no makeup, absolutely no makeup. So you have to plan it very carefully. If you have any issue before you take this exam, you have to let me know. You have to let me know in advance. Okay, if something that you have, or if you are in an emergency on this specific time frame, particularly the third options, if it happened to you but emergency, then please submit the legal documents, the excuse notes signed by whatever the authorities that you might have. Maybe a medical doctor sign on it. In any case, if you cannot take this final exam, then, and if you do not want to receive incomplete grade, then you need to let me know anyway. Otherwise, you will, without final exam, probably anyone may be able to receive an F, right? Because final exam weigh, I think, pretty significant weight. So if it is incomplete, then you have to complete it within, I believe, 4 weeks. So if you plan incomplete, that is really, really not a good idea. But in any case, if it's not avoidable, then you need to let me know. If it is urgent, then you need to thing is this: if that urgently happened, then you need to just give me the legal documents. Or if you let me know at least a week prior to this schedule, then you need to explain it. and then you need to let me know if you want to receive on I grade incomplete. Otherwise, you will receive a grade as is. All right. So we'll do steganographies today. Steganography. Oops. This is the last ones. Let me go up. Okay, steganographies. I'm going to explain the general concept and coding exercise, and the real hands-on will follow in the next sessions. So today is a week of Thanksgiving, right? And then probably next week I'll give you I'll let you know, right? I'll give you, we'll have one more lecture before your final exam, which means one more lecture and one week for your study day, okay? For your final exam, I want you to study. Okay. Steganography is a composite word. Stegano means covered. Graphia means writing. So whatever the writing may be covered. In this steganography, we cover the letter with a picture. Okay. It could be any format of pictures. It could be bitmap picture, it could be JPG. It doesn't really matter because we want to hide the text within a bit. Okay, actually that's bitmap based information hiding. Once text is hidden or covered by the image, as you look at image, it's almost impossible to identify, or at least to questions. Hey, this is not the same images. Given an image, we change only I believe if it is a color images, then we can say 2 to the power 24. So it'll be 2 to the power 24. So 2x over y 24 equals 16 million, right? 16 million. So we change only 1/16 millionth. Not only that, that small change. Not only that, we do not change the most significant bit, but we change the least significant bit. So it is the impact of a change is not even 1/16 millionth. I think it is 1/16 billionth or trillionth. So almost impossible to feel the difference. So it's difficult. A technique to prevent an opponent from reading your traffic, or for him to remain unaware that there is a traffic at all. That kinds of steganographical symptoms has been available historically, but what we want to do here, the technical and electronic steganographies. Here's our hierarchy. Steganography. Taxonomy of steganography, we can say technical steganography, linguistic steganographies, digital steganographies. Ours is more like digital steganographies, but it needs some technologies. There are many other ways. Linguistic steganographies, semograms or jargon code, covered ciphers, and historically there are many similar needs considered. Okay, steganography is also different from digital watermark. Steganography is a kind of a practice of hiding information within other information. So hiding text within a photo, for example. Digital watermarks is hidden within a document and can be shown to prove ownership. So this is a big difference, right? Only this is to identify the ownership, but the others is the whole message can be hidden and almost impossible to feel. Not only, even almost impossible to identify or detect. Like this, we have A, B, C, 3 images. Are they different? Or you cannot tell if they are different or the same? Almost impossible, right? So steganography is some of the techniques that we are using. So the concept underlying concept that we are using steganography is for each byte, if we think each byte, then we change the least significant bit, which is here. This is least significant bit. This is most significant bits. This tells us some, I don't know what this means, but if you look at the ASCII code tables, then you may be able to see how they look like. So if I bring, let's say here, ASCII tables, ASCII table, ASCII and binary tables, binary code tables. Let me see if there is any binary code that we may look. Okay, this is good ones. Okay, other than this, let's see what else. Maybe this. We know this is not really. But anyway, there's a code, the letter, okay, a character H. H is nothing but 0, 1, 0, 0, 1, 0, 0, 0. Okay. Um, and so what we want to do, if I have a character, character can be converted to a binary, right? If I say mercy, then M, there's a 01001101, and E here 011000101, MER are here 01110010. These things, bit of this, each bit of this, like 0 and 1, 0, 0, that can be, this will replace the image. So we say RGB image binary code. Is there something that we could see? Let's say here, not really binary code, but 255 in binary, then that is 11111, right? ASCII tables. Let's consider this. Okay, so for this color, then that is 3 consecutive bytes. 170 can be converted to binary code, 255 converted to binary code. This is a 1 byte, this is another byte for green, another byte for blue, another byte for red. So 0 means in binary code 00000000, right? So this color can be represented in 3 bytes according to this RGB code. It may be coded that way. Okay, so what happens? Okay, here. Okay, here. Therefore, so this image is nothing but the series of this kind of byte. So for each byte, or for every other byte, or every other 2 bytes, we do not know, right? How rarely the bytes can include the text bits. This byte includes a text bit in some sequence. So, okay, so a least significant bit embedding technology, and this technology is one of the easiest way that we can generate the steganographies. So message is a secret message that can be converted to binary code, and the image we can open up in binary code as well, and we change least significant bit with the bit of the messages. Then it will be stagger images. So they look the same, right? In RGB, left and right are 0 to 55 to 55 RGB. Green is only set and all others are zeros. So left and right is nothing but 0 to 55 0 colored. And middle ones 0 to 54 0. Only one difference. But to us, they look the same, right? So this kind of things that we want to use. Consider the bytes. If there is 254 in decimal, then that is F and E in hex, and in binary that is 11111110. That is 254, right? Then what is the significant bit? This or that? This is a significant bit. This is a least significant bit. So if we put this 0 or 1, it doesn't make this whole thing significantly different. They look very similar if we change only this one bit from here. But if we change this most significant bit, then entire will be significantly different. That is the idea, right? So we want to use LSB rather than MSB. Least significant bit rather than most significant bit. So let's say MC, multi-ecology, some of that character can be converted to a binary code, right? M can be 01001101. This is M. C means 01000011. This is C. And both uppercase in binary code. Assume that cover images, whatever that image, if we want to change this into this, how can we change it, right? I have 2 characters, which means 2 byte long, right? 2 byte long in character. That means how many bits? 16 bits. In order to embed this each of these bits in the image, then we need to use 16 byte long image values. How many bytes here? 1, 2, 3, 4, 5, 6, 7, 8, 9 bytes, 9, 10, 11, 12, 13. So at least 16 bytes given character, the images, then we can, 0 can be embedded here, the first byte, and 1 can be embedded in the second byte of image. Third bit of character can be embedded in the third byte of the images, so on and so forth, right? So in this way, this 0 can appear here, 1 can appear here, so it'll be 0, 1, and then 0 can be here, and 0 can be here. This should be 0 also. Okay, so FF can be converted to FF can be converted to FE. 1 should be here. So this actually 0, 0, but it should be 0, 1. This is a 0, 0, 0, 0. It should be 0, 1. 0, 0, 0, 0 remains the same. 0, originally 0 in the image, but text bit also 0, so stay 0. So that is a 0, 0. And 1 should be here, so it can be converted from FAB, FB, from FF to FE. That kind of things. Okay. Basically, this is the idea. If we program this, then there is steganography. So you can convert to steganographies. If you have images of this, and if you know each byte of this image contains the text bit, then from this you take out only 0. From this, you take out only 1. You take out only that bits from that, right? That is the way that you can get. That is changed. Yeah. Oh, this is. So, this is a steganography images, right? For each byte of these image files, you take only the least significant bit, collect all of this in this sequence, then that is the text. But here the question is, this image, every byte will contain the text value, or every other, or we do not know how frequently the text bit can appear in the image bytes. That is a key issue, right? So that is the reason is very hard. Okay? So we see the difference. There's a code in practice, but code will be discussed next week. So I wanted to have this concept behind how image can cover the text, covering text, and then extracting the text from the covered images. The idea is here this. This is original cover image. If I have this text in this sequence, then it'll be turned to that. So it'll be 0, 0, 0. This is the image. When you see this image, as I said, almost impossible to feel the difference. All right. I hope you can understand some of the concept behind steganographies. Okay.